Let's talk about a piece of technology you interact with every single day, but probably never ever see. We're diving into the invisible eyes that make our modern world work, optical proximity sensors.
I mean, really think about it. You stick your hands under a faucet, and poof, water comes out. You walk up to a supermarket door, and it just opens. How does it know you're there? There's no button, there's no tripwire. It just feels like magic, right?
Well, it turns out that magic is the same technology that connects all of these things. That safety beam on your garage door, the little sensor that stops the elevator from closing on you, even the super fast counters on a factory floor, they all share one secret weapon. A nifty little device called a photoelectric sensor.
Okay, so how do these things actually see the world? The secret behind the magic is actually incredibly simple and honestly pretty brilliant. Let's break down how it all works.
At its core, a photoelectric sensor is just having a conversation using a beam of light. You've got three main players on the team: an emitter, which is like the mouth that sends the light signal, a receiver, which is the ear that listens for it, and a detection circuit. That's the brain that decides what it all means. Emitter, receiver, and circuit. That's the whole setup. The whole process is this beautiful, simple three-step dance. 1. The emitter shoots out a focused beam of light. 2. That light travels across a space. And 3. The receiver notices a change. Either something breaks the beam, or the light bounces off something and comes back. The moment that change happens, bam! The circuit sends a signal, hey, something's here.
But, not all jobs are the same. You wouldn't use a giant crane to pick up a paperclip. And in the same way, you need different kinds of sensors for different tasks. So let's meet the team of specialists.
So at the highest level, these sensors have two main strategies. The first is called through beam, which is basically like setting up an invisible tripwire. You've got two separate boxes, and when an object passes between them and breaks that beam, you've got detection. The other strategy is reflective. This is where the emitter and receiver are in the same box, and it's looking for the light to bounce back, either off a special little mirror or off the object itself. And this is where you see the trade-offs. Over on the left, through beam is your long-distance champion. We're talking 30 meters or even more, and it's super reliable. But the catch is, you have to set up and align two different parts, so it's more expensive and complex. Way over on the other end, you've got diffuse. It's the easiest to set up, just one simple unit, and it's the cheapest. But its range is much shorter, and it really cares about the object's color and shininess. And then sitting right there in the sweet spot is retroreflective, which gives you a great balance of pretty good range and easy installation.
All right, so these sensors are pretty capable. But what happens when the world doesn't play fair? What about those tricky situations where objects seem almost perfectly designed to fool a beam of light? Well, that's when you have to call in the big guns.
So what is a sensor's number one enemy? Shiny stuff. Think about a metal can, a plastic water bottle, anything that's really reflective. To a regular retroreflective sensor, the glint off that can might look almost exactly like the reflection from its special mirror.
This problem actually has a name. It's called proxing. It's when that shiny object reflects so much light that it fools the sensor into thinking the beam was never broken at all. The can is right there, but to the sensor, it's completely invisible. So, how on earth do you solve that? Well, meet the hero of our story, the polarized retroreflective sensor. This is the modern standard for a reason. It's an absolutely brilliant solution designed specifically to defeat shiny objects and stop proxing in its tracks. The way this works is just chef's kiss. It's so clever. So the sensor sends out light that's polarized. Think of it as vibrating in just one direction. Now it hits a special reflector that does a little magic trick. It twists the light's polarization by exactly 90 degrees. The receiver, back at the sensor, has a filter on it that will only let in light that has done that 90-degree twist. A shiny soda can? It just reflects the light straight back, unchanged. The receiver completely ignores it. It's like a secret handshake that only the sensor and its real reflector know.
And the team of specialists doesn't stop there. You've got sensors with background suppression that can pick a single box off a conveyor belt and totally ignore the factory wall just inches behind it. You've got tiny fiber optic sensors that can snake into super tight or incredibly hot spaces. And there are even sensors that are trained to see specific colors, which is absolutely vital for things like packaging and printing.
This is all amazing stuff, but where is this all headed? Well, this technology is evolving way beyond a simple on or off switch. We are entering an era of truly intelligent sensors. Let's take a look at what that means.
See, for years, all a sensor could do was give you a yes or a no. An object is there or it isn't. But today's sensors, they're becoming talkative. They can give you precise distance data, they can tell you if their own lens is getting dirty, and they can communicate all of that information directly to the factory floor and up into the cloud.
And this isn't just a cool party trick. This intelligence has a massive, real-world impact. Using AI to predict when a sensor might fail or just needs a cleaning can reduce unplanned downtime in a factory by up to 30%. For a big manufacturer, that's not just a small saving. That can mean millions of dollars and a much, much more reliable system.
And the next wave of innovation isn't on the horizon, it's already here. We've got things like IO-Link, which is basically a universal language that makes any sensor plug and play. They're getting so small they can fit inside the gripper of a robot. They're being combined with LiDAR to create detailed 3D maps. And get this, they're even using types of light like shortwave infrared that can literally see right through dust and fog.
So this brings us right back to where we started. From just turning on a faucet to running an entire smart factory, these invisible eyes are getting smarter and more powerful at an incredible rate. And it really makes you wonder, what's the next everyday annoyance or the next huge industrial problem that they're going to solve for us?